We introduce CZsaw, a visual analytics system for investigative analysis problems where the data consists of collections of documents containing identified entities of various types. CZsaw's four major components are: first, data views derived from ideas in Georgia Tech's Jigsaw that display documents, entities, lists of entities, and node link visualizations. Second, a script consisting of statements generated by user interactions. These statements are interpreted by CZsaw to produce changes to the visualizations we described. Third, a dependency graph of script-generated data elements. And finally, a history view of all prior stages of an analysis. We now demonstrate the use of CZsaw to analyze the vast 2008 cell phone challenge. Recall that for this problem, the analyst has access to a data set of phone calls logged over a 10-day period. The goal is to identify by call density which phones belong to who and determine if new phones have replaced old ones in the Catalano-Vidro social network. The analyst starts with the information that Ferdinando Catalano's phone identifier is 200. The analyst first queries the database for phone 200 and adds the result to the graph. He then looks for all phones in contact with Ferdinando. To do this, he selects from the menu at the top of the graph view what he wants to display and how he wants to display it. Here, he chooses phones to be displayed as graph nodes and double-clicks the 200 phone node to reveal 6 phones. The analyst is interested in any changes to call patterns of Ferdinando's contacts. He thus requests a linear time-ordered view of phone usage over the 10-day period. The analyst now sees the dates of all phone calls made by Ferdinando's contacts. Looking for temporal patterns, he selectively highlights the connections for each phone and notices that phones 1, 2, 3, and 5 seem to stop making calls on June 7th. This leads him to suspect that each of these phones may have been replaced by new ones. To test this hypothesis, the analyst will do the analysis for one phone and then use the dependency graph's reuse capability to test the remaining phones. Starting with the new graph view, the analyst searches for phone number 1 and assigns the result to a variable he calls original phone. This variable is then added to the dependency graph. The analyst then finds contacts of phone 1 just as he did for Ferdinando and assigns them to a variable he calls phone contacts. This variable is now dependent on the variable original phone and is also added to the dependency graph. Now all of phone 1's contacts are displayed. To find a phone that may have replaced phone 1, the analyst would like to find a phone that shares many contacts. In the options dialog, he asks to see phones connected to the contacts of phone 1, naming this new group of phones replacement phone. He also asks that this group of phones be filtered for phones that have 10 or more of the same contacts as phone 1. Since phone 309 and phone 1 are the only phones connected to the majority of these contacts, the analyst hypothesizes that phone 309 may have replaced phone 1. To further strengthen this claim, the analyst compares the calling period of both phones. First, to simplify the view, he chooses to compact all the phone contacts into a single circle node. To see the calling pattern, he selects a linear layout of all the dates these phones were used. He assigns this set of dates to a variable named callDates, which again is added to the dependency graph. The analyst now easily sees that phone 1 was active during the first 8 days and then abruptly stopped, at which point phone 309 started to be used. The analyst thus concludes phone 309 is highly likely to be phone 1's replacement. The dependency graph which CZsaw builds based on the actions of the analyst can now be used to test similar hypotheses for the other phones by simply changing the value of the variable original phone to one of the other phones in the list. As the dependency graph suggests, any changes to a variable will propagate to its child nodes. Continuing, the analyst changes the value of the variable original phone successively to the remaining phones 2, 3, and 5. The analyst performs this reassignment in the search panel by selecting original phone from the drop-down menu. We can then easily replace phone 1 with phone 2, and the variables phone contacts, replacement phone, and call dates will all be updated based on this change. This update of the graph reveals phone 2's replacement phone is number 397. The linear layout of dates also shows that phone 397 started being used at the same time that phone 2 stopped being used. Repeating this process for phones 3 and 5, the analyst sees that they were replaced by phones 360 and 306. By allowing the analyst to skip many repetitive actions, the dependency graph essentially lets the analyst work at a much higher level.